Hello and welcome to this Functional Skills Maths Level 1 and Level 2 lesson on compound measures. The learning outcomes for this lesson are to calculate using compound measures, including speed, density and rates of pay. The linked learning. The linked learning goes back to ratios and unitary method. If you remember back to ratios, we use this word per. And per is very important because that actually defines a compound measure because it's something relative to something else. So it could be the number of grams you get per pound, and unitary method used to be 20 grams per pound, and then you could work out one or the other side of your ratio depending on whether you were giving a weight or given pounds. And that's all compound measures are. They are parts ratios where one of your sides is going to be the number one. The first compound measure we need to look at is speed, and speed combines distance with time. There are 3 or 4 main units for speed. We have miles per hour, kilometers per hour, and meters per second. Now, many of you probably remember when you did speed at school, the speed, distance, time triangle. Now, this was an easy way of remembering all of the combinations of a speed calculation. All you needed to remember was that distance was at the top and speed and time were at the lower 2 levels. And all you really needed to do was hide the thing that you didn't know, and it told you what to do with the 2 things that you did know. So if I was given the speed and the time of something, I would hide the distance, and it tells me to multiply the speed by the time. So when you're looking for the distance, it's speed times time. If, however, you were looking for the time, you'd cover up the time, and it tells you to divide the distance by the speed. And finally, if you were given the speed and you cover it up, it tells you to divide the distance by the time. So this was a quick and convenient way of remembering this specific compound measure, which is called the speed, distance, time triangle. There is also the ratio method where you can split your miles per hour as the 2 ratios. So if you're doing 60 miles per hour, you have a unitary ratio and you can work out both sides of the ratio. This goes for kilometers per hour and meters per second. So there are 2 ways to do these speed, distance, time problems. The triangle seems to be the most popular, but the most flexible and the one that allows you to do other types of compound measures is the ratio method. Just to show you how both methods work for each of the types of calculations. So if I drive at 30 miles an hour for 1 hour and 30 minutes, how far have I travelled? So we're looking for the distance, so we multiply the speed, which is 30 miles an hour, by the time. Now the time, because we're using miles per hour, has to be in hours. And you've got 1 hour and 30 minutes. So the 1 hour is 1 hour, but the 30 minutes needs to be turned into a decimal. So to go into decimals, divide by 60, and it becomes 0.5. So 1.5 hours, or 1 hour and 30 minutes, is 1.5 hours. 30 times 1.5 is 45 miles. If we did this using the ratio method, we know that our speed is 30 miles per every hour. I haven't got 1 hour, I've got 1.5 hours. So I multiply this by 1.5. And what I do to one side, I do to the other to get 45 miles in that 1.5 hours. So you can use either method, either the ratio method or the speed distance time triangle, or the speed distance time triangle. Let's look at our next example, and we'll use both methods again. So I've seen that it's a speed question, so if I've travelled at 90 miles in 2 hours and 50 minutes, how fast was I driving? I've got my speed distance triangle, remembering D is at the top and S and T are at the bottom. So I'm looking for the speed, so I cover this up, and it tells me to divide the distance by the time. So the distance is 90 miles, and the time is 2 hours, and it's got to be in a decimal, so I've got to convert 15 minutes into a decimal. So 15 minutes divided by 60 is 0.25 of an hour. So 90 divided by 2.25 gives me 40 miles per hour. So he was driving at 40 miles an hour to do 90 miles in 2 hours and 25 minutes. Let's look at the ratio method. We've got miles and we've got hours, and he does 90 miles in 2 hours, 0.25. I don't want 2.25, I want it in miles per 1 hour. So I divide this side by 2.25. I do the same on the other side, and I end up with 40 miles per hour. Let's look at our final type of question where we're looking for the time. So let's look at our two methods. We've got the speed distance time triangle where we're looking for the time. So we cover up the time and it tells us to divide distance by speed. So our distance is 190 miles divided by 40 miles an hour. And we end up with 4.75 hours. We don't talk like that in the real world. We don't say the journey took me 4.75 hours. We have 4 hours and then the 0.75, so we've got a decimal and we're coming out of a decimal, so we multiply it by 60. We end up with 45 minutes. Let's look at the ratio method. We've got miles per hour. We have a speed of 40 miles in 1 hour. The 190 miles goes on this side, it goes under the miles. So to work out our scale, divide 190 by 40 to give us our 4.75 as our scale. Multiply the other side by 4.75 and you end up with 4.75 hours. Exactly the same, we know the 4 is 4 hours and the 0.75 multiplied by 60 gives us 45 minutes. So we can use either method to work out our speed, distance and time. Now speed is a compound measure because it's a mixture of distance and time, miles and hours. And there are other compound units that you will come across in day-to-day life. So for example, every time you go to Tesco, you see something like this, where our Tesco pepper beef grill steaks cost you £5.89 per kilogram. So if you've got a certain amount, if you've got £2, you can work out how many kilograms that's going to give you. So anything like this is a compound measure, something that is made up of 2 units, in this case pounds and kilograms. So here's another really popular one that you come across, which is miles per gallon. So if I said my car did 45 miles per gallon, and I have 10 gallons in my tank, miles per gallon means I get 45 of these to every one of those. If I have a 10-gallon tank, I've multiplied that by 10. I multiply this by 10 and I know that one tank of fuel I can do 450 miles. So I don't have to remember triangles to do compound measures. If I can do the ratio method, then I can convert anything. Here's a functional skills type question on miles per gallon. Ellen drives from Bristol to Dover, so we go down from Bristol, across from Dover, and it's 205 miles. How many miles per gallon does she get if she uses 27 litres of fuel? So, in order to work out miles per gallon, I have to turn my litres into gallons. And in order to do this, they've given me the conversion. So let's do that first. I've got gallons and litres, and I'm being told 1 gallon is 4.5 litres. I don't have 4.5 litres, I have 27 litres. So how did I get from 4.5 to 27? I work out my scale, and I get 6. So my scale is 6, and what I do on one side, I do to the other. So I've used 6 gallons to do 205 miles. So I've got miles per gallon is what I'm after, and all I know at the moment is I did 205 miles using 6 gallons. In order to get miles per gallon, I need the unitary method to force this to be the number 1. So I've divided that by 6. If I divide the other side by 6, I get 34.16 recurring. So for the sake of rounding, I get roughly 34 miles per gallon from this journey. Other things you might come across is the rates of flow of something, how fast a container fills with water, how many drops can you get from an intravenous drip in a hospital, and something along those lines. So this is one of the units that you could use, which is litres per minute. So that is our compound measure. We're combining litres with minutes. So we have to put those units into our calculation. So a storage heater tank holds 12 gallons of water. So we've got gallons. How long would it take to fill at a rate of 3 litres per minute? So I've got a flow rate of litres per minute, and I do 3 litres per minute. So I need to put litres for this to work, and at the moment I've got 12 gallons. So lo and behold, they're going to give you the conversion rate between gallons and litres. I've got 1 gallon is 4.5 litres. I haven't got 1 gallon, I've got 12. So I've multiplied this side by 12. Multiply the other side by 12 and you get 54 litres. So my 12 gallons is actually 54 litres that I can now use on my flow rate, on my compound measure. So how did I get from 3 to 54? Work out your scale. And my scale is I've multiplied by 18. So I multiplied this side by 18 and it took 18 minutes to fill the tank. A new compound measure they would like you to understand in the new syllabus is density. And density is the compactness of a substance. So it's something to do with weight and the volume of the object. And it can be in grams per centimetre cubed or kilograms per metre cubed. Now you don't have to worry because you know on one side of your ratio you've got grams, and on the other side, the per side, you've got centimetres cubed, or you've got kilograms and metres cubed. So it is simply a something per something ratio. let's have a look at some density questions. So a piece of wood has a mass of 8 grams and a volume of 10 centimeters cubed. Work out the density of the wood. So we've got grams and centimeters cubed, and we know density is a measure of these two things where we've got to try and force the centimeters cubed to be the number 1. So if we've got 8 grams per 10 centimeters cubed, to get its density in this format per centimeter cubed, we have to force this to be the number 1. So we divide it by 10. That means we divide this side by 10 to get 0.8. So the density is 0.8 grams per every centimetre cubed. And that gets you your 2 marks. Here's another density question. The volume of a piece of metal that has a mass of 300 grams has a density of 6 grams per centimetre cubed. So this is our strap line. Our grams per centimetre cubed is 6 of them to every one of those. We haven't got 6 grams, we've been given 300 grams. So to find our scale, divide 300 by 6 to get 50. So 6 has been multiplied by 50 to give us the 300. Multiply this by 50, and it tells us in order to get 300 grams in weight, we need 50 centimeters cubed for our volume. And this keeps our density at 6 grams per centimeter cubed. Here's another level 2 question on density. So here's your strap line. Iron has a density of 7.8 grams for every centimetre cubed. A solid iron statue has a mass of 877.5 grams. So the 877.5 must live on this side of my ratio. So how did I get from here to here? Dead easy. The bottom number divided by the top number. Use your calculator, and it's 112.5 as my scale. So I've multiplied this side by 112.5. I do the same on the other side. So my statue that weighs this much must have a volume of this. And that's the correct answer for 2 marks. 1 mark for the answer, 1 mark for your working out. Something else that is specified in the curriculum now is that you need to understand rates of pay. And rates of pay are also compound measures. So basically, it's going to tell you an amount of money per, and then it's going to be hours, months, or years. So you can use your ratio method to work out the answers. So a premium telephone line charges £3.60 per minute. This is your strap line, £3.60 for every minute. And then there's a fixed cost of £1.20. How much would half an hour's cost cost? My minutes is going to be 30 minutes. So I've multiplied 1 by 30 to get my minutes. I need to multiply the other side by 30 to get how much it's going to cost me. So my phone call at £3.60 a minute is going to cost me £108, and don't forget I need to add my £1 fixed cost. So that gives me a total of £109.20. Here's another compound measure using money. Leanna hires a cleaning company to clean her house. They charge £15 per hour. she was charged £48.75. So that lives under this side. How long did it take to clean Leanna's house? So how did I get from £15 to £48.75? £48.75 divided by 15 gives me my scale, 3.25. So I've multiplied this by 3.25. I do the same on the other side, and it's taken them 3.25 hours. Now, we don't talk like that in the real world. We know this is 3 hours, and to convert my decimal time into minutes, I multiply by 60. So it took them 3 hours and 15 minutes to clean the house. There are lots and lots of compound measures. You can almost put any two combinations of things together. If you put a per in the middle, it tells us that the one on the right is the one that's measured with a 1. So it could be the number of drops per hour on a drip. It could be anything per anything. This slash symbol sometimes means per in maths, so it could be the number of litres per day. It could be anything per anything. So those common compound measures are out there in the real world. The number of grams per pence that you get for your packet of crisps. So that completes our learning outcome, which was to calculate using compound measures, including speed, density, and rates of pay. Okay, let's have a quick recap with our buzzwords. The first buzzword we came across was speed. These are very specific problems you are most likely to get in your exam. So speeds are miles per hour, or kilometres per hour, or metres per second. There's two ways of dealing with them. You can use the ratio method, where you have miles against hours, and the per means you're first forcing the hour to be the number 1, so 40 miles per hour. Or you can use your speed, distance, time triangle, remembering distance goes on the top, and you cover up the thing you don't know. It tells you what to do with the two things you do know. Per, in mathematics, means the thing that's following it is the number 1. So in our ratio, the thing that is on the right, the second unit that's on the right in our compound measure, is the number 1. Density is a very specific compound measure where it combines weight with volume. So this can be a combination of grams per centimetre cubed or kilograms per metre cubed. Do not get flustered. All it is a strap line for a ratio. There's a relationship between grams and centimetres cubed. And finally, a rate means something per something. So it's usually pay rates that we talk about, or earning rates, and that would be a number of pounds per hour or minute or day. And again, it's just a strap line for a ratio. And that completes this learning outcome and this lesson. If you have any questions or queries, or you want more practice in anything that's in this video, then please talk to your tutor. I hope you've enjoyed this video,